Okay, so we just talked about the 45, 45, 90 triangle. Now let's talk about a 30, 60, 90 triangle. So where this is derived from is an equilateral triangle. And what we know about an equilateral triangle is all the sides are the same, and therefore all my angles are going to be the same. Okay, so each angle is going to be equal to 60 degrees. Let's go ahead and call this side 2. Okay. Now, what we talk about with this one is we look at finding the altitude of the triangle. So, the altitude of a triangle is kind of like the height, just like speed when you're flying. They talk about your altitude, it's how high above the ground you are. Imagine this is the ground, and would be the height of the airplane. Okay. So, if they want us to find this dotted line, what we notice is we've got a triangle right here. So, I'm going to pull that triangle off. It's a 90-degree angle. This is 60, and this is 30. I know this is 2, and if this is an equilateral triangle, when I create my altitude, this side right here this whole side is cut directly in half. So this would be 1. Now again, I could use trig, but Pythagorean theorem, especially with small numbers, is pretty quick. So if I go ahead and use this, I'm going to get 1 squared plus the other leg, which let's just call it b squared, equals 2 squared. 1 squared is 1, b squared is b squared, and 2 squared is 4. And then I want to get b squared by itself, so I'm going to subtract 1 from both sides. And I get b squared equals 3. I'm going to square root both sides, and I get b equals root 3. Okay, so that means the altitude is root 3. So if I create a similar chart from up above, if I look opposite my 30-degree angle, opposite my 60-degree angle, and opposite my 90-degree angle, let's look what we are. So opposite my 30-degree angle, I had a side length of 1. Opposite my 60-degree angle, I had a side length of root 3. And opposite my 90-degree angle, I had a side length of root 2. Now, if I kept doing this with some different equilateral triangles of different size, let's go ahead and call this 4. Let's go ahead and call this, I don't know, 6. And then let's go ahead and call this 5. If I did this with each of these, what I would get, and again, I could use Pythagorean theorem just like we kind of skipped up above a bit. I could use Pythagorean theorem, go through the whole step. This side would be 2. And what ends up happening for this altitude is it's 2 root 3. And if I fill in each of these, I get 3 root 3. And I get, this one's kind of hard. It could be 2.5 or it could be 5 over 2. I'm going to go ahead and keep it as 5 over 2. And then this altitude turns out to be 5 over 2 root 3. So I'm going to write all these in. So I get 2, 4, and 2 root 3. I get 3, 6, and 3 root 3. And I get, opposite the 35 over 2, and 5, and 5 over 2 root 3. Now, the order that I wrote that in might have led to what you notice, but what we notice is the side opposite the 30, to get the side opposite the 90, we multiply by 2. 2 times 2 is 4, 3 times 2 is 6, even 5 over 2 times 2 is 5. And then what we end up having is this, the side opposite the 60, is always my short side, root 3. So what that comes out to look like is if I draw a 30, 60, 90 triangle, I'm going to exaggerate it a little. I'm going to lay it on its side. They're typically drawn like this. My short side, I'm going to call A. My hypotenuse, I'm going to call 2A. And again, opposite the 90, opposite the 30. And the side opposite the 60 is always A root 3.